Chapter 5 Design. It's best to start here. Design sounds like a trivial consideration when there are so many more pressing concerns, such as writing a loop, controlling decision flow, and so on. But none of these concerns are as important as deciding how you attack a program. You need to think about the design of your solution and how to go about getting it ready for programming. Writing a program can be like having a huge problem to solve and trying to figure out the best way to solve it. Let's start by considering some problems in the real world and figuring out how we might solve them from a design point of view. Then we'll consider designs for problems for a computer. In this chapter, top-down design, stepwise refinement. What is top-down design? Imagine a satellite view of the Earth. Google Earth will come to mind. Let's say you want to find your house. Initially, you only see the outline of your state, and then as you zoom in, everything becomes clearer. You can make out the rivers, lakes, and maybe even the contours. Zooming in closer allows you to see more detail. Google Earth provides a great analogy of how top-down design works. The outline of the land mass is the most generic picture. As you zoom in, you recognize more and more things. Top-down design works the same way. At first we have one big problem, but we try to break it into separate, manageable tasks, just as an amorphous landmass, upon closer inspection, becomes separate countries and states. Programming tasks can often be too general at first, but after you consider them, you decide how to subdivide them to make them more manageable. Always start by making an outline of your problem. Try to break your problem into separate tasks, then work on refining those tasks so that you can write simple code to execute them. Real-world problems and design. If you recall, we talked about algorithms in Chapter 1, and they are an important consideration in designing a solution to any problem. An algorithm is a finite set of instructions to solve a problem. As mentioned before, those steps can repeat as well as be skipped according to what happens in a given step. As your programming tasks become more complicated, it's imperative that you have an organizational plan in place before you write your first line of code. This plan is what we call the design of the solution. In computer programming terms, there is one kind of design that is very important: top-down design. With top-down design, you consider the outline, the rough sketch of what you want your program to do without worrying about the details. The opposite of that is called bottom-up design, and involves focusing on the smaller tasks first before looking at the big picture. Top-down design gives the programmer the organizational structure to attack a big program. With top-down design, you subdivide a big problem into little tasks. Each of these tasks can then be worked on and tested for effectiveness. There are several reasons for designing a program before starting to write code. The design will allow you to consider realistically what you need to write to make the program work. A little planning on your part now can prevent you from running into serious problems later. Imagine if you were to undertake some huge project, like building a house, without considering all the different aspects first. You might run out of money in the middle of construction. So first, let's consider some simple examples. Example 1. Let's say I want to go on a hike during summer break. I am in the White Mountains of New Hampshire. I need to consider a few things before I go. If I have never hiked before, I might think that there isn't much to do other than follow a trail. However, many times ignorant hikers run into problems if the weather turns bad. They didn't pack enough water or food, or they get lost. These are the general tasks I would consider first. 1. Pick a trail. 2. Pack a knapsack. 3. Wear the right clothing. 4. Find someone to hike with. 5. Tell someone else where we are going. 6. Go. Each of these tasks could be elaborated on, since I am not really sure of the details for any of these steps. Now look at a more elaborate list of tasks. 1. Pick a trail. Decide whether you want to do an overnight trip or a day trip. Decide the length of the trail you want to take. This decision will affect how much clothing and food you bring. 2. Pack a knapsack. Get food ready. Get water ready. Get all necessary maps and a compass. Include first aid items. Include miscellaneous items. 3. Wear the right clothing. Find both short sleeve and long sleeve shirts. Include warmer fleece. Decide whether you will wear pants or shorts. Include rain gear. 4. Find someone to hike with. Call various friends who like to walk in the woods all day. If friends are not available, call a relative. 5. Tell someone else where we are going. Call and leave a voicemail. Email name of the trail we are taking. 6. Go. Purchase a parking permit. Drive car to base of trail. Lock car and keep keys. This is just a simple example This is just a simple example to show the difference between a list of tasks that show little detail and another list which is more explicit. It can seem trivial, but if you don't outline each of the big tasks first, you may run into problems later. I have, for example, driven to the base of the trail and then realized I had to drive another 10 miles to get a parking permit first. If you are planning on hiking a long trail during daylight hours, the extra time spent getting the permit can affect your plans. You may not be able to get in and out from your destination before dark. Outlining the major tasks before the minor tasks serves two purposes. The first is one of organization. Considering the big problem as separate tasks allows you to focus on them and develop them in more thoroughly. The second purpose is that you can delegate work to someone else if you have already outlined what needs to be accomplished. In the hiking example, you can delegate the decision of where to go. That person then completes all of the subtasks of choosing a trail, acquiring maps, getting tent gear, and so on. Let's look at another example and list the tasks involved. Example 2. Let's say I have been collecting VHS tape videos for years and recently switched to collecting DVDs. I purchased several movies on DVD that I already had on VHS, and I now have 2 copies, one in each format. I decide to take inventory and get rid of the old duplicate VHS movies. How should I approach this problem? The top-down design approach is where you delineate the big tasks and then break those tasks into smaller tasks. The video collection problem involves these tasks. 1. Make a list of all movies. 2. Next to each movie, classify it as DVD, VHS, or both. 3. Separate the movies with the tag both from those without that tag. 4. Throw out the videos of the both collection. 5. Alphabetize the entire collection. If I want to refine the tasks in this problem, I would take a task and add more steps. Look at what I would do here. 1. Make a list of all movies. Get the title of each movie and then alphabetize those movies. 2. Next to each movie, write DVD, VHS, or both. 3. Separate the movies with the tag both from those without the tag. 4. Throw out the videos of the both collection. Put them into boxes and deliver to a Goodwill location. Change all words both to DVD. 5. Alphabetize the entire collection. Notice how steps 1 and 4 became more detailed in the second list. We refined those steps by giving them more detail. This process is known as stepwise refinement. Stepwise refinement is useful because it helps the programmer outline the code he must write. In step 1, I could write a separate function called getTitle and another called alphabetized list. When I set out to write this code, I will have a clear idea of what I need to do to accomplish if I don't refine the steps. I have a less of an idea of what I need to do, since step 1 initially only says make a list of all movies. Stepwise refinement is important because it trains the programmer to move step by step, the way a computer works. Every time you refine a task by making it more specific, you are getting closer to being able to write these instructions in a programming language. As a beginning programmer, you need to learn how to organize solutions in a systematic way so that they can be processed. If your tasks are too vague, then chances are you will have a tough time writing them in a language. Here is a third example where we write the big tasks first and then refine them in the second list. Example 3. Suppose I have a list of customers and I want to get a list of those who have more than 3 DVDs overdue from my rental shop. Here are the tasks I need to think of first. 1. Separate customers who are renting a DVD from those who are not renting any. 2. Find out how many rentals each person has. 3. Look at each person who has more than 3 DVDs rented out and check the dates they were due. 4. Make a list of these people. Let's look at each of these steps to see which ones can be refined with more explicit tasks. 1. Separate customers who are renting a DVD from those who are not renting any. 2. Find out how many rentals each person has. Count the number of rentals currently out with a person. Separate those with more than 3 from those with fewer than 3. 3. Look at each person who has more than 3 DVDs rented out and check the dates they were due. Put a flag next to each person with more than 3 late DVDs. 4. Make a list of those who were flagged from the previous step. What we have done in both examples is to try to give more detail for some of the steps involved. If I focus on small tasks first, I might lose sight of the big picture. This approach of looking at small tasks first is called a bottom-up approach. Example 4. Here is another example of taking a large task and breaking it into smaller tasks using a top-down approach. Consider what you would do if you were buying a car. Most of us would not just go to the store and buy it without doing a few separate tasks. Each major task must be broken to subtasks into subtasks that give more detail. See Table 5.1. Table 5.1. Buying a car. Task. Steps to complete the task. How much money do I have? Check first bank account. Check second bank account. Add all accounts. Task. Choose a car. Select make. Select type, sedan, coupe, SUV, etc. Select color. Pay money. Get bank. Check ready. Bring check to dealer. Back to the text. Buying a car is really a set of other smaller tasks, like finding out how much money you can spend and making choices about the car. You would need to choose a car's make, its type, and its color before deciding whether the car was the one you wanted to buy. You also have to get the money together for the car. Are you going to need a bank check with it written instead of a personal check? Most likely. As you can see, the tasks on the left have been broken down on the right to make each task more clearly defined. Computer problems and design. Now we will examine some practical examples that you can program. Each example involves a main task that requires some refinement. As you read each example, try to identify which task will be refined and how it will be refined. Many of the problems that we solve on a computer involve some kind of numeric tasks. The numeric work you do will generally be in the most refined section of the program. Example 1. In this example, we will consider a math problem involving prime numbers. We want to make a list of all the primes less than or equal to the number 500. This sounds like a big task, since there are 500 numbers to check and we have to keep a list of all those that are prime. Let's start by looking at the primes less than 10. There are 4 primes less than the number 1. 1 is not considered a prime number. 2, 3, 5, and 7. Now we have to find out which numbers in the number set 1, 2, 499, 500 are prime. Let's look at this algorithm. 1. Start a number counter called mynum at 2. Since 2 is the first number, we will check. 2. Check to see whether mynum is prime. 3. If mynum is prime, write it down. 4. Increase mynum by 1 so that you can check the next number. 5. Go back to step 2 until you hit 501. Most of these steps are clear, but we need to elaborate on how we would determine whether a number is prime. So step 2 needs to be refined. In this step, we would have to articulate how a prime number is recognized. We would have to think about what we could write in programming terms that would allow the computer to recognize a prime number. In fact, it is not that difficult a task, but it is good that we have drawn attention to it by separating that work from the other steps in the algorithm. Example 2. In this example, we find the youngest person in a group of 50 people. At first, this problem can seem difficult to program. However, I have developed a list of steps that you can follow to complete this task. Again, as with the previous example, consider what steps need to be clarified. 1. Find the first person's birth date. 2. Find the next person's birth date. Retain the more recent birth date. 3. Go back to step 2 if there are more people. 4. Stop when there are no more people to check. The step that needs the most refinement is step 2, where we have to retain the most recent birth date. That would involve some subtasks of comparing years of birth, and if those were the same, we would compare months and then days if necessary. 1. Find the first person's birth date. Get the year, the month, and the day. 2. Find the next person's birth date. Get the year, the month, and the day. Retain the more recent birth date. Compare years, then months if necessary, and days if necessary. 3. Go back to step 2 if there are more people. Check the list of people. 4. Stop when there are no more people to check. Both of these are examples of top-down design. As you continue to learn about programming and encounter more elaborate programs, you will find this perspective useful. The process of developing separate blocks of code to accomplish separate tasks called modules or functions will be developed in Chapter 8. Summary. Each time you break a big problem into other smaller problems, you are using a process of top-down design, which we also call stepwise refinement. Each set of tasks is refined by adding more steps to indicate how the big task is accomplished. By trying to break your tasks into other smaller tasks, you are starting to develop a modular approach to a program. This approach will be ideal for learning about functions in Chapter 8.